This is a video from section 3.9 in a Calculus 1 class. A water trough is 10 meters long and a cross section has the shape of an isosceles trapezoid that's 30 centimeters wide at the bottom, 80 centimeters wide at the top, and has a height of 50 centimeters. If the trough is being filled at a rate of 0.2 cubic meters per minute, how fast is the water level rising when the water is 30 centimeters deep? And so this is telling me that we want dH dt when h is equal to 30 centimeters, which is the same as 0.3 meters. Now, I drew a cross section of an isosceles trapezoid. We already know that dV dt is 0.2 cubic meters per minute. I'm going to let h equal the height of the water level. Okay, and I label that here. That's h. Now, if I take 0.3 and I add 2a, that's going to be the width of the water level at the top. 0.3 meters is the width of the water level at the bottom. That's here. Now, 0.8 meters is the width of the cross section of that trapezoid at the top. So that's the topmost width you can have. Now, I broke it up accordingly. Notice how the distance from here to here, right? I'll label it in blue. From here to here is the same as the distance from here to here. So that's 0.3. And I label this distance here, I'll label this in black. That's x, and this distance is x. And they have to be the same thing because we have an isosceles trapezoid. I need to know what that value of x is. And so if I take 0.3 and I add 2x, I get 0.8. So that tells me 2x is equal to 0.5, and so x is equal to 0.25. And again, 0.3 plus 2a is the width of the water level at the top, where 0.3 is the width of the water level at the bottom. And we want to know what dH dt is when h is equal to 30 centimeters, which is 0.3 meters. So I'm transforming everything in terms of meters. Now, we need to know a relationship. Okay, now, incidentally, the volume of this water trough is the following. I'm taking the area of that trapezoid and then I'm multiplying by the depth, which is 10 meters. So in other words, I'm going to take 1/2 the height times the sum of the bases, right? So I'm taking 1/2 h times 0.3 plus 0.3 plus 2a. So this is the area of the trapezoid. And then I'm going to multiply by 10. And where did I get that 10? So again, the trough is 10 meters long, so that's the depth. So I took the area of the trapezoid and I multiplied it by the depth. And when I simplify this, 1/2 of 10 is 5. And so the volume is 5h times 0.6 plus 2a. Now the question becomes, how does a and h relate to each other? Now, let's look at the picture here. I'm going to use similar triangles, okay? Now, remember x is 0.25, and remember I needed that. So I claim A is to H. So basically width is to height as 0.25 is to 0.5. So A is to H as 0.25 is to 0.5. But that says A is to H as 1 is to 2. Cross multiply. So I'm going to get H is equal to 2A. And so therefore, if I divide both sides by 2, I get A equals 1/2 H. So that's how A and H are related to each other. So right here, I'm going to replace A with 1/2 H. And so when I do that, I get the volume is 5H times 0.6 plus H. You could have done it here, which that's fine. Now, distribute. So 5H times 0.6 is 3H. 5H times H is 5H squared, and I'm going to add those quantities together. Now, dV dt is 3 dH dt plus 10H dH dt. dV dt is 0.2. We don't know dH dt, right? That's what we're looking for. The height is 0.3. Remember, 30 centimeters is the same as 0.3 meters. So again, 0.2 equals 3 dH dt plus 10 times 0.3 dH dt. So 0.2 is equal to 6 dH dt. Divide through by 6. So dH dt is equal to 0.2 over 6 meters per minute. But I claim that's equal to 1 over 30 meters per minute. Now, if we want this in centimeters per minute, which the book did, I can take 1 over 30 and multiply by 100 because 100 centimeters is the same as 1 meter. So 1 over 30 times 100 over 1 is the same as 100 over 30, which is equal to 10/3. And so dH dt is the same as 10/3 centimeters per minute. And you can conclude this by saying the height is increasing at a rate of 10/3 centimeters per minute. And that right there is problem 27. Okay, thank you.